screencast will provide a demonstration of Acknowledge's estimate cardiac output from arterial blood pressure analysis routine. This is a new feature in Acknowledge 4.4 and complements the existing arterial blood pressure analysis routine that has been in previous versions of Acknowledge. This particular algorithm uses the Lillstrand and Zander estimator to calculate stroke volume and cardiac output on a cycle-by-cycle basis. In order to run the analysis routine, you need a file that contains a continuous non-invasive blood pressure waveform, such as the signal that comes from a NIBP 100D non-invasive blood pressure analysis module. The results from the analysis routine are output to either a spreadsheet or journal file, and you also have options for creating new waveforms. In this case, you will get 3 new waveforms, one for heart rate, one for stroke volume, and finally cardiac output. To perform this demonstration, I'm actually using one of the sample files that is installed with Acknowledge. This is a sample waveform coming from the NIBP 100D. So in the top channel we have the raw pulsatile blood pressure signal, and this is detected at the fingers using the transducers that come with the NIBP device. Down below, the software has calculated pulse rate, systolic, diastolic and mean blood pressure values on a cycle-by-cycle basis. To add stroke volume and cardiac output, we have to go to the analysis menu, and under hemodynamics there is a new option down there, estimate cardiac output from ABP. When we select this option, a dialog appears. First off, it's asking us to select the channel that contains the blood pressure waveform. In this case it's channel 1. And down below we've got 3 primary options. The first one is the standard recognized estimate for cardiac output from a resting male. The second one is the same for a female subject. And the third one allows you to put in your own estimation. Now, the estimation is required in order to run the analysis routine. I'm going to use the average male resting, the default, at 5.6 litres a minute. Now, sub to that you have the option to analyze the entire file or to analyze just your areas of interest using the focus areas option. So in this example, I'm going to use the entire graph. The software now closes the other channels out, hides them, so that we can focus on the arterial blood pressure waveform. And this operates in the same fashion as the blood pressure analysis routine, that it asks you to highlight a single cycle, and it wants us to select from one systolic value to the next systolic value of an entire cycle. So to make that a little bit easier, I'm going to zoom in so we have a better look, and I'm just going to select one of these waveforms, go from cycle to cycle, and then a button appears immediately above the graph window. Cycle is selected. Once I've selected that, the software runs through and it provides the calculations. So I had the preferences set to provide new channels and to output the results to a spreadsheet. In the spreadsheet view, we have the values in a cycle-by-cycle basis, the first cycle, the start time, the heart rate, the cardiac output and the stroke volume. The cardiac output starts at 5.6 because that was the estimated value that we put in. Now you can see the values changing as the subject is breathing in and out, and if I compress the view down, we can see that we've now got these extra 3 channels in here. Heart rate, cardiac output, and stroke volume. And then the asterisk and the D are marking the points of systolic and diastolic on the primary blood pressure waveform. If we highlight an area, for example, I can select cardiac output. So this is giving me the mean cardiac output for this selected area here. I can highlight an area 5.4, 4.9, 4.4, 5.2. So this is a resting adult male subject, and our values are displayed for stroke volume, which is the pink channel, green channel, cardiac output, and heart rate. 89 beats per minute for this period, and stroke volume. So here are my individual values. And again, if we go into Excel, we have these values available for further analysis in a spreadsheet format. So it's a straightforward analysis to run. You need a clean arterial blood pressure waveform, something that you'll get from the NIBP 100D non-invasive blood pressure waveform, but it will work on other systems providing that the waveform is continuous. In other words, it needs to be a beat by beat measurement, and it has to be calibrated as well. This value here is measured, and these are the values in millimeters of mercury. And once you've got a good, clean, continuous non-invasive blood pressure signal, you can then run the analysis by going to the analysis menu, to hemodynamics, and selecting estimate cardiac output from ABP. And that concludes this demonstration of the new estimate cardiac output from ABP.